Hello and welcome. In today's video we are looking at this idea of relative atomic mass, and this is actually specifically for the higher tier for chemistry unit 2 for GCSE science. Now relative atomic mass, we can have an abbreviation for that. We can use capital A with a small r, that just means relative atomic mass. And when we're looking at relative atomic mass, what we're doing is we're comparing the mass of an atom to one special atom, and that is that of carbon 12. So we call this carbon 12. And we call it carbon 12 because it has a mass number of 12, and we compare every other atom to this one. So for example, hydrogen over here, the relative atomic mass is 1, and that means that if we compare hydrogen to carbon, that means the mass number, or the mass, is 12 times less than that of carbon. If you look at something like oxygen, it has a higher relative atomic mass, and you can compare these two masses and work out the proportion and how much, by proportion, how much more it is. Magnesium, slightly simpler to work out. You can see it has a relative atomic mass of 24, and that means it just has an atomic mass double that of carbon 12. So you can easily compare the masses. Now you might be saying, well, hold on a minute, these numbers are just the same as I see on the periodic table, and we call them atomic masses, and we've learned in class they're called the atomic mass. In actual fact, these numbers are very close to the atomic mass, if not the same, but the reason we call it the relative atomic mass is, one, because we're comparing to carbon 12, but also these numbers are the average of the isotopes for these elements. So it's the average mass number of the isotopes that exist. Now we don't really see then much of a difference when we're comparing atomic masses to relative atomic masses, but when you look at something like chlorine, you'll see it has a relative atomic mass of 35.5, and if you remember, this number here tells you protons plus neutrons, and if you've got a 0.5 in there, well, we must have a half a proton or half a neutron. In actual fact, that's not the case. This is the relative atomic mass, and the reason why we have 35.5 is because it's an average mass of the different isotopes of chlorine. And if you look at the isotopes of chlorine, you see the most common ones have a mass number of 35 and 36, and because they exist in certain proportions, we can average that out to 35.5. So the relative atomic mass for chlorine is 35.5, and that's why you see that number there in the periodic table. Sometimes you might see 36, and 36 is often used for calculations of looking at what the atom looks like and so on, but in actual fact, relative atomic mass is 35.5. So you should be able to explain that relative atomic mass means the mass of an element compared to that of carbon 12, and you should understand that it's an average mass of the isotopes that exist in nature.